Dear students, next class will be about the juggling the tennis balls. But, well, in fact, the robot will not toss the balls. It will displace them on the table. So there will be uh, there will be three stands on the table, but there will be only two balls, and the balls will be placed here randomly, so the system will don't know which place is empty. So first of all, the robot must check each place uh, and remember which place is empty, and then start juggling. So it will move, uh, let's assume clockwise the ball, so this ball will be placed here, then this will be placed here, then this will be placed here, and so on. So there in the system there should be two processes. The first process should be checking empty place, and then uh, replacing the balls. So if you check the stands at the beginning, you should not come back to the checking process during the juggling. Okay, so now I need to tell you something about inputs and outputs of the robot, because you will use some sensors and some actuators, you will use the gripper and so on. Each robot has its own input and output module. It's a green one. The module is connected with the robot by the fiber optic. It's here, and it's so configured so the robot can see the outputs, red or yeah, this outputs, and blue inputs. Each slice has here two outputs and here two inputs. There are also slices more complicated. Here you can see that each slice has four outputs and four inputs. Each connection has its own light, so if it is active, the light is active. So this is the module of the robot A. This is the module also of robot A. This is of the module of the robot B. This is the largest one. Uh, there are many different diploma works connected to this. So these are connections for different grippers, for example. And this is the module of the robot C. And here you can see that each slice has the supply, the brown, it's a positive connection, and blue one is negative, and with no additional color, here are signals. Here are signals uh, coming to the inputs, and here are signals going out from the outputs. And so if you have sensor or actuator, you need to use the signal, and also you need to supply the sensor. So each each connections can be realized here, yeah, on this module. the supply and the signal. So it's quite convenient. So here you can see four inputs. So you can see here 1, 2, 3, 4 uh, places for signals, and 1, 2, 3, 4 places for positive supply and negative also. Mm. All the grippers in our lab are supplied by compressed air. You can see here the pipes, and here is the valve. This valve has a single coil and single electromagnet, so it's monostable, so it has only one stable configuration. If we remove the power from the coil, the valve will automatically switch back. So if we supply the coil, and the compressed air will go through one pipe, and if we remove the supply from the coil, the compressed air will go through the second pipe. So one position of the valve will open the gripper, and second position of the valve will close the gripper. The gripper is equipped with two inductive sensors. They recognize the open and closed configuration of the gripper. One sensor is here, and one is on the opposite side. And third sensor is an optical one sensor. This is destined for recognition of the object in the gripper. This sensor uses triangulation method, and we can set the distance of the recognized object in this sensor, and other sensors on KUKA robots are simply optical sensors which recognize reflected light. So this is the bigger brother of the gripper, of this gripper. So this is a smaller one version, and this is the bigger one version of the same construction of the gripper. And you can see also here the sensors, inductive sensors here, and second one is here, and this is the optical sensor. And this is the valve on the robot B. So here you can see two coils, and this valve is B stable. So it will remember the position. If we power this coil and remove the power, the configuration of the valve will be stable, so it will switch to the right hand side. Even if we remove the power from the coil, it will be stable. If we supply this coil, it will switch to left hand side and also will remember its position even if we remove the supply from the coil. So you need to properly manage the power of those two coils, because if this is supplied, this coil will not work. Yeah, we need to remove the power from this one, and then this will work and will switch the valve to left hand side. So this is the compressed air coming from the compressor, and here go out two small pipes going to this big gripper. You can see it here. And this is proper configuration of the control of the gripper. Even if we lose the power, yeah, the connection can be destroyed in any way. Even if we lose the power of the coil, the valve will remember its position. And this is the third gripper, and you can see here two sensors. This recognize the closed gripper, and here is behind this connection. This sensor will recognize open gripper, and here is optical sensor. So this is the third robot C. And here you can see the valve. This robot is also equipped with a valve with single coil. And in this case, you will not use direct this signal, this physical signal going to the valve. You will use another signals which simulate the valve with two coils. The simulation of two coils is realized on the robot A by these three relays. So you will send the signals to coils of these two relays. You will use two signals, and they create a signal which supply the coil of the valve. Yeah, so this is a hardware simulation on robot A, and on robot C there is a software simulation. So you will use two flags which simulate two signals going to a valve equipped with two coils. If you start program creation, you need to set proper tool. Yeah. Until now we have used usually a pen, but now you will use gripper, so you need to create a tool of proper dimensions. And in the case of the grippers, we will not calibrate it using 4 points method, but you will write dimensions of the tool directly to the system. So you will measure it and insert the dimensions. You can do it here. Setup, measure, tool, and here on this list you will choose numeric input. And you will choose proper tool, proper number of the tool, one of the 16 different tools which can be created in the system, and you will write the dimensions. In the robot system you have access to different folders. Until now we have written different programs in Folgen folder, but also you have access to macros and UPS. Macros are short programs which use only input and output signals. You cannot write any motion instructions in macro. And UPS is similar to the main program. It's similar to Folge. And here you can write all the motion instructions and also input-output instructions. So if you will want to open or close the gripper, you need to use a sequence of different instructions, because we are going to create a rectangular signal. Yeah? Set the output to 1, wait a while, and switch it back to 0. It's enough. Yeah, such a short rectangular signal is enough for switching the valve. So if you create and open new macro, you will see the screen like this. You can see here a program pointer, so it means that you can also execute a macro which you have created. And we choose from the button, we choose AMF. Using this button, you can change the output A. It's from German Ausgang. You can change the marker M, or you can change the flag F. We are going to switch the output to 1, wait a while, and switch it to 0. So if we press this button, you can see such a formula, and you can choose number of the output, and you can assign to the output logical 1. It will be ein. It's German. It's from German language. Ein means logical 1. Aus means logical 0. E means Eingang, input, and A means Ausgang, output. And after setting the output to 1, we need to wait a while. So we choose from the context menu wait. And in the wait instruction, we have 3 options. We will choose wait time. So we can see such a formula. It's German here, and you can set the time, the waiting time. Yeah, so 5 if we write here 5, we obtain a half of second. So it will be enough. So such a short rectangular signal can switch the valve. Yeah, so we switch the output to 1, wait a while, then we switch it to 0, and then we need to wait for the signal that will confirm that the gripper is opened or it's closed. Yeah? So if there will go something wrong and the gripper will not open, we should not allow the robot to continue its work. Yeah? So we choose once again wait, and then we choose uh, we choose bis, yeah, and we obtain such a formula. We choose bis here, and here we can set the signal on which we are waiting for. So we are waiting for the input, so E, and we can choose the number of the input here. And all the procedure of the opening or closing the gripper will look like this. Set to 1, wait a time, set to 0, and wait for the confirmation of the reconfiguration of the gripper. So you should create your own macro for opening and another macro for closing the gripper. If you create your macro and test it, you can run it, press deadman switch and green button, and then the robot will execute this macro and you can observe if the gripper is working properly. After all, you can close the macro. Cancel program will mean that you close the edition of the program. It will be saved automatically. If you want to execute an input-output instruction in the main program, or you want to call the macro which you have created, you should press PLC open in the context menu. Then under the motion instruction you will see another line in blue color, and here you can write any input-output instruction, or you can call a subprogram, or you can call the macro for opening or closing gripper. All such instructions must be connected with some motion instructions. So the robot is a mechanical construction, so the motion and the input-output signals must be synchronized. And we obtain the synchronization of the signals with robot by connection all those blue instructions with chosen motion instruction. So if robot will finish this motion instruction, then it will start execute any blue instructions, any PLC instructions. Okay, so we have pressed PLC open, we have such a image, and then we can choose this button. This allows us to execute any macro or any sub-program, any UP. Okay, so after pressing this, we can choose what we want to execute. We choose macro in our case, and here we choose the number of the macro. If you want to close or open the gripper, we choose the number of macro we have already created. And here on the right hand side there is a condition when it should be executed. If on the right hand side there is logical 1, this will be executed. If 0, it will be omitted. So in our case we want to execute the gripper. So we write here logical 1, and then it will be always executed. We can, if we want to close the gripper, for example, it will make sense only if the ball is present, if the optical sensor recognize the ball, then it makes sense closing the gripper. So we can choose here, instead of logical 1, we can choose input Eingang and choose the number of the input which is connected to the optical sensor. It can look like this. The macro will be executed only if input 1 is active. In the same way, we can execute subroutine or subprogram, UP. Instead of macro, you can choose also UP. And the formula will look like this. And here also you can set the condition for the execution of selected subroutine. This condition can be more complicated. You can expand this logical expression, and the formula can be longer, larger, and you can use or, and operators, parentheses, negations, and so on. Also in main program you can set the output marker on flag. You have access to it also here in main program, not only in macro. And it will look like this. You can choose here what you want to change. Output, Ausgang, marker or flag. And you can assign any signals, any flags as you wish. So in this case, if you choose here a flag, you can assign to flag state of the input. So in this case, in this way, you can remember which place is empty, which place contain the ball, then the sensor will return 1, and which place don't contain the ball, then the sensor will be not active, and the sensor will return 0. So there will be 3 places, so you can use 3 flags for them and remember the configuration of the balls. And using those flags, you can set the system to make decision how to start juggling. You can observe the flags. If you want to debug your program, you can observe the inputs, outputs, you can observe the flags, you can also change the state of the flags. Everything is here in menu monitor. And finally, subroutines, the folder UPS. As I said, UPS looks like Folge. There is no Warte auf Folge start. That's the difference. If you want to execute the subroutine which you have created, you can execute this single routine. You have here program pointer. The only condition is that the first instruction will be point to point. If you start with linear motion, you will not be able to execute it. And you should remember and you should know it that inside one subroutine you can execute another one. Yeah? And here in the KUKA robot system, there is no if instruction. So if you want to set some conditions, you should put some instructions into the subroutine and set here the condition when the subroutine and those instructions inside it should be executed. So that's the only way for setting some conditions in your program. So more or less that's all. I wish you a lot from this video so that you can complete the task more or less on your own.